Assalamu alaikum. Welcome back to my channel. In my last video, teached you, I teach you and I show you substation, base substation concept. So I hope you remember. So this one, regarding this one, actually I have to tell you again, this one can be various. And some area it can be increased 66 to more value, depend on the distance, depend on the country, everything. And this value also 240 or 215 or something, anything. Also country to country can be differ. So keep in your mind, this one very important, this voltage can be differ place to place. So again, I am telling from the beginning. So this is, we have to, before that, I want to tell you something. We calculate from reverse. Okay. We have to come from the wiring device up to the transformer or up to transformer. So reverse calculation. So first you have to calculate the wiring device, then the dB, then SMDB, that means sub main distribution board, then MDB, main distribution board, or we can call MV panel, and then the transformer, it will goes to transformer. Okay, so I hope you understand in my from my previous video. So let's start calculation. So I told in my previous video, I will teach you in next video calculating how to calculate, how to select the panel, everything. So focus your mind. It's very important. So I have a light, let's say light, in one apartment or one room, whatever, so whatever area you have. Let's go with the Excel sheet. So we will go Excel because it's easier. Excel. Okay, I will take a new page. So I have a light. So we will consider this on apartment dash 01. Okay. In this apartment, I have, let's say, total light. I have light numbers, maybe 20 something. And then the socket. Let's consider around 30. No, we will put 20 also. Then we will go for the water heater. Let's say we have two bathrooms, so two number of water heater and AC. Let's consider six numbers or five numbers. Okay. So cooker in the kitchen we have one, and let's say pumps. uh, let's say two pumps. We have light, socket, water heater, air conditioner, cooker, and pumps. Let's put dishwasher one. What else we have? We can have microwave. So microwave. Let's put one. And fridge. Let's put one. What else? So let's consider this one. So here you see I put light, socket, water heater, AC, cooker, pump, dishwasher, microwave, fridge. So this one, when you are making a design drawing, you don't know correctly because you are designing the electrical. You don't know correctly what kind of light you will use because this light selection depend on the ID people or architectural. So maybe they will use different kind of lights. So sockets, okay, we know how much we need. But this one also, as per the furniture design, can be plus or minus. Okay, so as per the design, maybe some area you have to use a floor box socket. So floor sockets, it meaning. If you go to the Google floor box, so something like that, if you see there, it have some sockets inside. You see these sockets? So depend. So it's in the designing stage, we can consider normally. Okay, AC can be as per the room, it can be differ. So in designing stage, if you have a correct design, architectural design, you can calculate also. So if you are electrical, you don't know how much ton you need, you will not know. But if you know mechanical also, you can calculate. So this is the coordinates, and you have to coordinate each service. Okay. So as of now, we consider we don't know the actual load. So we have to take, okay, the load from the Kaharma regulation. The Kaharma regulation very important for the. I am working in Qatar, so I need to go with the Kaharma regulation. But let's go document. I think I downloaded. Mm, I didn't download. Okay, let's download first. Type Kaharma regulation. Uh, let's type regulation. In Kaharama regulation, it is electricity. Okay, here. This one, let's download this one. I will save. Okay, in desktop. That's better. And open. Let's keep open this one. So in the Kaharama regulation is very important. This one can be differ country to country. For Qatar is Kaharama regulation. For Dubai there is something else. And other country there is something else. Place to place can be differ. So here now let's close this one. Okay, here I have 20 nits of light. So if you go to the Kaharma regulation, you can see they have given general notes, general loads. Uh, as I remember, the light is 50 watts. You have to consider light as a 50 watts. So let's search here light search. So I have many result. Okay, accessories. So let's go light. Okay, these are the symbols. If you are new, you can learn the symbols from here. It's available everything. Now we will go to the light. Okay, designing consideration we have here. Okay, we will go for the light. 1 minute. Lighting here. Circuit breaker. I think it's available here. Here, maybe not here. So I don't want to just tell you by mind because I want to show you the source also where I got this source. So this is power factor. Let's type load. Okay, here, everything here available. Table number, let's remember the page. Number 78. Okay, so this is the lighting. Current demand to be assumed. So sum of voltage of all luminaire or assume 50 watts for each lighting point. Chandelier lighting point 200 up to 500 watts. So we have to go the maximum one. Lamp voltage plus losses of associated control. You can read this one. So here, as per the Kaharma regulation, they have told us consider one light point. So 50 watts. Okay. So let's put uh, watts here. Okay, let's put W. So let's put W here. So one light is 50 watts. Okay. The socket, how much they have tell us? The socket, 13 ampere socket outlet, you should consider each 100 watts. Let's put 100 watts here. This meaning single socket, okay, not double, okay. Actual rating appliance, reflex outlet. Okay. The actual rating appliance meaning, I will tell you this one is belongs to some like dishwasher, microwave. That one I will that one tell you as per my knowledge. So water heater 1.5. So water heater 1.5. That meaning 1500 watts. Okay. So what else? Washing machine dryer 1.5. So washing machine. Did I put washing machine? Okay, washing machine. Let's put washing machine. It's including dryer. So let's put one number 1500 watts. Okay. So cooker 300. Cooker. Here 3000. Okay. Then the fridge is 300. And what else? Motors. Actual rating air conditioner 1.2 each ton. So I will consider each AC 2 tons. So 2 ton means 2400 each. So I will put 2004. Because 1 ton, if you have 10 by 10 by 10 room, you need minimum 1.5 ton to get a good cool. So pump, it's a normal pump. We will consider 200 watts. Dishwasher, it's a big thing. So we will go with the washing machine, same 1500. Also microwave, I will go with the same. Okay, so it's mentioned here microwave. Okay, dishwasher, it's already mentioned 1500. Okay, so let's multiple this one, equal, click, multiple command, click, enter. So let's drag it. So let's total, auto sum. So I have 26,200 watts. That meaning 26.200 kilowatt. And let's consider 26.2. Okay, meaning I divided this one into 1000. Let's divide it. Equal this one divided by 1000. So I have 26.2 kilovolt. So let's consider the building. I have a building here. So this is apartment A. So I have, okay, let's put B here. What is it? Fill, okay, B. I think C will come. No, let's go apartment A1. I forget how to do that one. Okay, I have 7 apartment. So let's consider this one building. I have 7 apartment by 10 floor. So this one. So I have sun fields areas. Okay, 10 floor. Consider that one. No need to go bigger. So this one copy here. Okay. So this is my apartment. I have 7 apartment each floor, and I have 10 floor and by 7 apartments. So here what I have get here, this value 26.2, this is one apartment, apartment 1. This is belongs to this one. Okay. So I have to put a DB here, distribution board. So this distribution value is 26.2. I hope you understand. So let's go little bit here. So I have 26.2. This is one apartment. So if I have one apartment 26.2, this 7 apartment I need to put one SMDB. Okay. Okay, let's keep it. It's like this. So this 1 dB, 2 dB, 3 dB, 4, 5, 6, 7. This 7 dB connected to one SMDB. So if I have one SMDB in each floor, then full I will have 10 SMDB. So there will be another DB. I have to put service DB. Service. Okay. This one for what? This one for the socket which run in the corridors and light. This is not belongs to apartment. So service DB. So total 8 dB connected to one SMDB. So this is service DB, service. Okay, so each SMDB connected. So I have 10 SMDB. This 10 SMDB, let's delete this. This 10 SMDB will connect to 1 MDB. So let's color this one green. So this green all DB, these greens will go to connect this SMDB. This SMDB all connect to 1 MDB. This separate color. So this one I have to make bigger. Because it's all connected to here. Okay. This MDB connected to one transformer. That's TX. So let's like this, different color. This transformer will connect to HV. You can call this an MDB or slash MV panel. So this HV, so different color. And like this. So let's say I have 3 building like this. Okay. That meaning this one insert. Why I am keeping distance? Because this is subdivision out of the building. So it's not connected with the building. So this SMD copy one, another one. So I need have 3 building. So if I have 3 building, that meaning I have to keep 3 MDB. Then 3 transformers. But HV will be what? 1. Okay. So Kaharama connection will come here first. And it will give connection here 1, 2, 3. Then it will go to here 1, 2, 3. And it will connect each one. Then it will connect here. Okay. I hope you understand. So here, so let's copy this one. Now let's type here this one 26.2. Okay. So now I'm going to keep a space. Okay, 1, 2, 3. So here you can put alternator. Okay, again, I have to select here. If you are good in Excel, you can do it very fast. I am not good in Excel. So, yeah. Okay, not this one. Yes. So I will delete this one because I will copy later. So each building I have how much? 26.2. Copy. So I will go here after here. Okay. So this one will be same. This one will be same, same, same. Please focus what I am doing. So service dB, maybe I will put 2 kilo or 5 kilowatts. Let's go with the 5. Okay. Let's make white also. Copy, Control C, Control V. Okay. Now this is the kilowatt. So how much I will have total kilowatt each SMDB? This total. Okay. So equal sum, open bracket from here to here. So I will have 188 kilowatts. Let's copy this one here. Okay. How much I will have NDB value? So I will connect this one. Let's make like this. Okay, equal, open bracket, plus, I will go. If you know better, if you have idea to do better way, you can do it. I cannot see here. Sorry, let's little far. And this one plus here plus. So my SMDB value is 1695 kilowatts. No, I will not come to transformer now. I will come later. Okay, now here's the concept. Each DB we have 26.2 kilowatts, and each SMDB my total kilowatts 188.4, and each MDB MB panel or MDB I have 1695.6 kilowatts. Okay, so in the designing concept, now we have to select the amperage, the incoming breaker. How we can select? Again, Kaharama regulation. So if you go to the this panel, sorry, this table, they have given all formula. So here you see this voltage drop. And let's go with the, yeah, here. This is metering. The transformer I told you this is transformer incoming top bus stack 2500 ampere. They have put 2500 ampere. There's another transformer 1800. This is the MB panel. Front view. Actually, they call switch gear also this one. It will come cubical panel. So read the total Kaharama if you want to be a good designer or good draftsman, whatever you want to be. Now my problem, where is this calculation I want to show you? Okay, this is amperage calculation. This is voltage drop calculation. The problem, if you don't know the correct page number, you have to search one by one. It will take too much time. Yeah, should be somewhere here. And you should know how to search also. The problem I am doing in my as per experience, I don't used to go this Kaharama table every time because it is in my mind. So I am very less going to Kaharama book and search for everything. If I want certain thing, only I will search for that and then close it. So I don't used to go every time this karma regulation. So I don't know correctly where is this formula located. Anyhow, the formula is very simple, but I want to show you. Even you can check in the Google also. So it's coming again. Hold it up. So somewhere will be here. It's very easy. So I will go to the next page. You have to take this is KW multiple into 1000. Then below we will be there will be a line. So here root 3. Where is the root mark? Okay, I have to take from this mark root 3. This one. Okay. So if you are using 24 volt 440, so this one. Wait. Yes, 1 minute. So for the root 3, I don't know how to type. So for that one, I will go to the calculator. So just type 3 and this one. So let's copy 1.73. So we will go 1.73 here. And this is multiple mark. So 440 into power factor 0.9. So this is the calculation. You can calculate the ampere. So if you go to the Kaharma table, so there was this. So you see here, they have given 1 minute. So voltage definition I show somewhere. Because in Qatar we used for 15 volt. So 1 minute. Again, I have to search voltage. So it can be country to country different. So I told you before this one, same thing. Here. So rated voltage in Qatar they are using 240 and 415. Okay, so we will use same here also. So let's go with 440 with 415. So check your regulation in the country and you will know what you have to use. So this is the formula. So let's consider, let's make calculation for 1 kilowatt. So equal, so this is 1. So we will put 1 multiple with this 1000. So this is, we will close bracket. Okay. Then again divide open bracket. So 1.73 into 415 into 0.9. So close bracket. So we are getting 1.547. So we will keep in our mind, let's go with 1.55. So this is our major uh, formula. Assalamu alaikum wa rahmatullahi wa barakatuh. So we will keep this 1.55 as a base ampere for 1 kilowatt. So now let's go to our calculation. So we have 26.2. So let's give another one. Insert. So 26.2 meaning is equal this one multiple 1.55. So this is 40. Okay. So this is actual ampere. So this is actual load. Okay. And this one actual ampere. Amp. We will put amp. Okay. So I will go with another one. Okay. So this will be continued up to here. So what is my SMDB? 292.02. Okay. So we are having 40.61 amperage as per our load. So this is actual load. So there is the one issue in the actual load. Let's say we have in our apartment or in our building or in our office, we have 20 sockets. We will not use 20 socket every time. One time, I mean one time we will not use. AC one time we will not put all the AC one time. Maybe some AC we will off, some AC we will off. Water heater it will not work for 22 hours. Cooker it will not work for 22 hours. So what will happen? There is one called diversity factor. Diversity factor. We have to go calculate diversity factor. Again, we have to go to the Kaharma. You type diversity factor. Diversity. Okay. Ah, the cool moves. So let's search for the diversity factor. Okay, I have selected this some text. Okay, search. Let's maybe my spelling wrong. Factor. Power factor. I know the place. So I can search for it. So I know the page. Let's go with the page. It's somewhere here. Okay. Someone will comment. You are taking too much time to search for the factors and everything. I am sorry, I don't remember everything in my page where to search, but this one I remember. Uh, Somewhere here I saw. It's a table, very small table. Yeah, this is for the load. See, the next page is the diversity vector. Okay, this is the diversity factor. Let's make this one smaller. Okay. So general load, light and socket, we can go with the 60%, air conditioning 90%, cooker 40%, water heater 30%, other 50%. So we go to the next one again. Okay, I think I deleted that one. I should not delete. So let's copy this all. I'm sorry, copy this all. Now control is Okay, okay. So I don't have anything here, so let's paste it here. Okay, it's everything gone. I should paste first. I didn't save also. Okay, let's keep this one. I will do it in very fast. So this one I need it here. Okay, enter. Insert. Insert. I will just recreate and I will okay, let's calculate one, then we will go to the old one. So I have actual load 26.2. So let's go to this one. This is actual load 26.2. So we can copy later. And then actual ampere, this is multiple by 1.55. Okay. Okay, multiple mark. This is actual load. Let's put hold on. Actual load. Okay. Actual amp. Okay. So let's calculate the diversity factor. So light I have how much? 0 0.6. So let's go 0 0.6. Socket 0 0.6 also. Water heater how much I have? 0 0.3. So 0.3. AC I have point 9. So we will go 0.9. Cooker we have zero point 0.4. So 0 0.4. Pumps we will go to the other 0.5. 0.5. Dishwasher this one also we can go to the other. So dishwasher other, microwave for other, fridge for other, washing machine for other. So let's multiply this one equal into this one. So calculate, let's delete this one. We can copy this one so it will calculate. Double click. No, it's not calculating. So we can do this one, right? Okay. So this is okay, this is divided by this one. So let's delete this one. So this is actual load. I will put AL. This is diversity factor. So DF. This is demanded load. TL. Okay. This is unit watt. UW. We will put UW. Okay. So UW for unit watt, AW actual load, DUF is diversity factor, this DL is demanded load. So how much we need demanded load? 17.3. Why we are calculating this one? Because every wiring device, everything we will not use 24 hours. So my actual load 17.3. Sorry, demanded load. Demanded load. Okay. So demanded load 17 point, let's go 17.3. So I will go 17.3. So this ampere, if we will calculate point with the demanded load, how much it will come? Equal this one into 1.55. So amp DL. Amp from DL. Okay. So why I am showing M from DL? There is a mistake I did. 1.5. Okay, 26. So here you will see, let's make a box. Okay. Actual load, we have 26.2. Actual amp from the actual load, 40.61. Demanded load, 17.3. Amp from DL, amp from demanded load, 26.3. So in which amp, there's the two amp I have here, this two. So when we are selecting a breaker, I will prefer from the actual amp. Okay. So why? In case if you have a function, let's say you have a 50-60 people, not 50-60 people or too many people, maybe everything can be, there is a situation can come, everything can be on. And another case, maybe you will bring in another additional device. We don't know what kind of device you will bring, something a special device, so you will not have any problem. So I will go with the breaker, DB breaker. So with the 40, so I will go with the available market available breaker, maybe 60. We will go always bigger. So not gonna get the actual actual ampere breaker. We will go with the 60 something. Okay. So I hope you understand. So we will, the selected breaker will be 60 ampere. So I don't want to type here. So this is, let it keep it here. So this is number one. So this is floor number one. Okay. So this will continue all up to here. Let's consider all up to here. So this one I told you 5 kilowatts. This one diversity factor, everything we can go with 2.5, something like that. This is just like for calculation. Okay. So here the HMDB we will sum this one, and the actual ampere we have to go equal into 1.55. Okay, 300. So demanded load we can sum. Now here we have to go. How come this two? This one actual amp. Okay, this one should be like this. When you're making a calculation, little careful. Small mistake can give you big issues. So this is the sum of demanded load. So the amperage from the demanded load 1.5. I think I didn't put the multiple point. Oh, why like this? Okay, here you will see different amperage. So here you don't have to take the breaker size from the actual load. Why? There's no possibility seven apartment have function and seven apartment full with the people. So here we will go with the demanded load ampere. So this I will make it red. And SMDB we will go with the demanded with load, and then the DB we will go with the actual load for the breaker. Okay. So this will be continued. So copy for the 10th floor, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I hope you understand. This is SFDB. This one will go to MDB. Okay, so this is in the floor. So MDB we can reduce little bit. So this is MDB. So this MDB, okay, MDB or we can call MB. Okay, so we can make center. Let's rotate this text better this way. Okay, now I will go with okay. So this load will be calculated by 188.4 into, so let's put another one. So here we can calculate because we have 10 floor, 188.4 into 10. This is the load. So we can format this one. Okay, this is the 188.4 into 10 apartment. That meaning 1884 kilowatts we have. Okay, this is the actual kilowatt total. So what is the ampere will be? I will put another one. One 88 this one equal this into 1.55. Okay. Now this one I will make the formatting. Click from here here. So 2900 something. So here what I took from the actual load. The problem we don't have to take the actual load, we have to go with the demanded load. So how much? 123. I told you the reason uh, there is this possibility is very less, which every uh, apartment or every floor you will use all the equipment. So there's 1915 ampere. Okay. So main breaker. So if you go to the switchboard, you see the switchboard. This is a cubicle panel. Okay. So there will be a design where this guy. Again, I have to search. 1 minute. This one visible is very fast. Or this. Okay, here. So this one, you have cubicle panel. See this one? 630 ampere. 630 ampere, 630 ampere. Okay. So the each SMDB will connect it to each panel of from here. Here. So this is 320. So we can go with the 123 can be go to the 200 or something. This doesn't mean in this is one single breaker will come. It's all goes to where each panel from here. 1, 2, 3. So this one connected to maybe this panel connected to here. Okay. Another panel connected to here. Okay. something like that. So this cubicle panel connected to here, this cubicle panel here, and this generator panel somewhere. This is for the generator, this is for the transformer. Transformer connected here. From the transformer, it will connect here. From here, it will go every cables. Okay. From here, it will separate to the assembly. If you see my previous like this, okay. ZLV transformer to this MDB panel. So it's connected. So there will be synchronized panel. If you have a generator, it will connect here also. You can learn from here. So don't expect me to explain everything, each and everything. You have to learn yourself also. Just I am guiding you how to do the design. Okay. So this each panel will connect. So this one in the Excel, this one can be divided into four. Maybe this two, this one go to one breaker, divide it into 10 actually, and this one go to one breaker, this one go to one breaker, okay, and this maybe this four can be one cubic panel, and this four one cubic panel, and this two can be one cubic panel. From that cubic panel, and it can go here. Uh, yes, it can be go controlled from here. Okay, this higher voltage. Higher ampere breakers. Okay, 630, something like that. I hope you understand. Okay, so how we will know this one? Now everything I am showing by panel and the Excel sheet, everything. There is whole one drawing we are used to make single line diagram. It's look like this, something like this. Okay, so let's consider this all SMDB. And here, this is not SMDB, this is SMDB. So we have connected all the DBs. So let's say 1, 2, 3, 4, 5, 6. And this is SMDB. From SMDB, it will goes to uh, MV panel or for the switch gear. So let's go to the Google switch. Let's type switch gear. Oh, MV panel. We will type MV panel SLD. Oh, this MV switch gear SLD. We can go with this. So image. So if you go here, let's get easier one. Okay, let's go with this. You see here, see this one connecting everything. Okay, maybe it's not visible for you. Uh, okay, let's take this one. It's video. Yeah, it's video. Okay, I will try to bring one file and I will show you two again. But try to understand for now. Okay, this is the connection method up to MV panel. So you know how to select a breaker for the DB, how to select a breaker for the SMDB, and how to calculate this uh, ampere, everything, and diversity factors, and how to calculate the load. Let me check how many hours gone. Let me check because it is more than 1 hour. It will be make boring for you. Okay, it is less than 60 minutes, so I will go with a little more detail. So here now the next part is selecting cable and how to select cables. Everything I will teach you. Now let's go with the transformer selection. So we know how much load we have. 1236 kilowatts. Okay. So this one always we go with the 30% spare load. So let's go 1236 kilowatts. So let's multiple, let's make a big equal into 3, meaning 30% equal into point 0.3. So 370. So calculate this one plus this. So we have 1606.8 kilowatts. That's the, this one you have to convert to kVA. How to calculate kVA? Multiple this one with PF, power factor. We saw power factor point 0.9. So 1446 to kVA. Keep in remember, if you want to calculate the kilowatts, if you want to convert kilovolt to kVA, just multiple into power factor. If you want to calculate kVA to kilowatts, divide by multiple factor, power factor. Okay. So 1446.12 kVA. So as per the Kaharama regulation, so what transformer we can select? Okay. So before we saw if inside the building we will go with the oil type, sorry, dry type. If outside the building it's oil type. This is general. If I am mistake, correct me in the comments. Okay, let's search for the transformer. Oh, will go with the kVA. So it will find very fast. Okay. So here, where increase of load require that a transformer rated less than 800 kVA is changed for one of 800 kVA or greater rating will be necessary. So if you have a less than 800 kVA, you have to use 800 kVA. So we have more than 800. So let's go with another same. Okay, we can go with the 1600 kVA transform. So how much we have? 1446. We can go with 1600. So this is the available supply transformer rating. So we can go with 1600. See, I didn't see up. I'm searching. Okay, 1600 kVA. So required transformer for this one. Let's connect this one. 1000. Let's format this one to okay. This one to here and 1600 kVA transformer. Okay, this is how we select. So this cubic panel. So I have this is I didn't do this one. So 10 SMDB. So if you have 10 SMDB, you can go with the 1 MB panel and where it is one in the cubic panel, you can give it to the supplier and you can say, I have 10 panel. This is designed by them. Okay. So they will design this one. Okay. And I hope you understand very well. So let's say if I have a generator, how it will come. So this I will delete. Okay, I hope you understand this one. Now I did it. Just I delete. So this is kVA TX transform. Okay. So if your generator, if you want to supply generator, you have to decide yourself what are the service will provide the generator. Generator, what are the which service it will cover? Maybe only service DB or all the apartment. It's depend on the design. If you want to cover all the apartment with the generator also, you have to go with the same. Okay, then what will happen? There will be a mechanical interlock here. That meaning like the mechanical interlock inside the panel. Something, something like something like this. Okay, see this one connecting each other. Okay, this is transformer. This is panel. I want to have. I have one panel, but in the next video I will show you this one. This you see this M. This is mechanical interlock connecting each other. Okay, something like that. Then you can put one SMDB, uh, ESMDB, meaning emergency submain distribution board. So what will happen? This mechanical interlock. So where there will be a generator here. So can put generator. So this is mechanical interlock. So this is it will be inside the panel. Okay, you have to understand that one. This one will be inside the panel. So you will so go to the this one. This is the generator. Okay. So there will be inside the panel mechanical interlock. So you see transformer here, generator here. This is bus bar chamber. So there will be inside the mechanical interlock. So what it will do, if you want to supply a full apartment generator by generator, so you have to choose same kVA generator. Okay, 1600 kVA. Generator. Okay. So it's depend on the generator what you have, how many generator you will get it. If you have two generator, there will be a synchronizing panel. If you have one generator, maybe not required. Uh, so what will happen? This is mechanical interlock. Okay, this is mechanical interlock. So in case of power loss from the government, that meaning this is from the government loss, this will supply the power here. So this mechanical interlock will connect to here. When the power comes, this will be disconnected. Okay, generator will off. This is design. This one the inner technical machinery inner technical. That meaning this one example this one how it is inside. This is not our duty. This is the panel specialist will do the that thing. So each thing there's a specialist. So our concept that is finished on this stage. Okay. Now there is another stage I will teach you in next video. Cable selection. So there's a small uh, the small overall what the idea is. You know how to calculate the dB. You know how to take the actual load. You know how to calculate actual ampere. You know how to calculate the demand load. And you know how to take the amperage from the demand load. And you know how to select the breaker for the dB. And you know the same for the SMDB. You know the same for the MDB. From there, you know how to select the transformer load. Okay, in the next video, I will teach you everything related to cable selection. So it will be included with the voltage drop also. So inshallah, up to next video, we will meet in next video. Until then, take care. Bye. If there is any mistake, if you found, maybe when I'm telling one thing in the beginning and then the middle of thing, if I change anything, just mention in the command because I'm going with the flow. Maybe I have done some one or two mistakes, so I will correct it. So until next video, take care. Bye. So we will meet next in next video. When I'm making a next video, I will come with to you with the complete. Uh, I will try to bring a complete SLD, for example. So I was telling you this is if I have a five building, same concept. There will be five transformer will be here. Okay. If it is a five building, it is all other either a five substation will be there. If you have single substation, there will be five transformer. Something like this. Here we have three transformer. This is transformer one, two, three. Okay, and there's ISO another transformer. You should know how to read this one. I will teach you in the example. Not only know, you have to know how to design this one. In next video, I will teach you everything. Okay, okay. There is a so this is three transformer one, two, three. So in the next video, until we meet next video, take care. Bye. Assalamu alaikum wa rahmatullahi wa barakatuh.